yeah, model development. And specifically today we are going to look at the model evaluation while using the classification methods or what we call supervised methods. Okay, do you see? Do you see? Can you see the slide currently? Ni nampak eh? Ni nampak eh? Right, kejap eh. Okay. So I'm going to introduce you. This will be measures that been used on the model that after we have developed the model, yeah. After we have developed the model on the classification, using classification, we need to look at the model, whether this model would be the best model or we can improve the model. Okay. First of all, when we look at the model development, we will be related to the underfit and overfit problems, yeah. And I will introduce you with this problem, and later on we are going to look at the metrics or the parameter being used and how we are going to improve the classification accuracy, so that it will be related to the training, the methods of training and testing. Okay, and finally will be some other issues related to the modeling itself. Yeah. Okay, this will be the one that we have done before. Yeah. If you see, yeah, this will be the illustration of the classification. Remember, in the classification that we are going to have data set. Yeah, we are using the historical data set, and the historical data set will be divided into training and also test, and majority will be the training set. Okay, and those who are going those data that will be for the testing purpose, all the class level will be removed. This will be removed, yeah. So the class level will be removed, and when we test the data, when we test the so-called model, yeah, we are going to look at what are the predicted, yeah, class level based on the model and compare it to the actual class level. Okay, so this will be the concept of accuracy. So here, if you look at best model is applied after we compare performance of several models using the test set. It means that several models, if you look at several models, what would be defined by this this point is that a model that been developed for the classification purpose would be not necessary using one algorithm, yeah. So you might want to use other algorithms as well, and then make comparison between these models. Okay, so if you remember, what would be other algorithms apart from J48 or decision tree for classification? Anybody? Other algorithm?
A star.
A star, alright. Other than that?
MLP.
MLP, okay. Other than that?
Logistic regression.
Okay, logistic regression. Okay, so these are among algorithms that you might have gone through, yeah, like A star. A star would be quite popular for the searching, yeah. Yeah, it can be implemented in the classification, but it's quite a high level application. Okay, if you look at MLP, this will be very common because this is a very basic ANN, yeah, ANN. And currently, if you look at the application of ANN, would be towards to what we call the algorithm under the deep learning, yeah, under the deep learning category, like CNN, RNN, and so forth. Okay, and meanwhile, linear regression. Okay, so linear regression would be more for prediction. Prediction means that it will be different, prediction and classification. So linear regression would be on the predicting the real value, like you want to predicting the temperature, yeah, for tomorrow. Okay, but if you want to apply it for the classification, which is more related to the nominal data set, yeah, I mean in terms of the target or the class level, you might want to use what we call as the logistic regression, yeah. So logistic regression means that it can transform the value of numeric into nominal by representing transforming in using the log, yeah, log representation, or what you call, it could be part of the sigmoid, I can't remember, transformation. Okay, so this would be other algorithms. So it means that you can use multiple, or you can apply several types of algorithms in terms of doing the classification, and this model need to be evaluated. Okay, let's have a look at the definitions of related to the model, problems of the model. If you look at the generalization, okay, firstly, what is generalization? Means that the ability to make generalization or for the outcome or for the output based on certain types of data. I mean, it can learn, yeah, and can make some kind of generalization for certain patterns. Like you have two class level, okay. So this model able to make a generalization for class level A. So this will be a standard pattern for class A, and then it can generate what kind of another type of knowledge that representing the pattern of class B. Okay, and it also could be it could be a good algorithm. Certain algorithm would be very good, and it can find a new knowledge that would be never been seen before, and this is what we want to try. We want to have from the machine learning algorithms. Okay, meanwhile there will be another kind what we call problems, which is relevance to overfitting and underfitting, yeah. So if you look at training, yeah, if you look at the process, this will be related to the training process. Okay, it means that you have using, or you have developed a model giving some kind of outcome that we call it as a overfit model. Okay, what does it mean by overfit? Means that the generalization cannot be we unsure this generalization really useful or not, yeah. So this because unreliable, yeah. The learning will be done, the learning process will be really focusing on the training data set, yeah. I will show you later on how we can see this kind of overfit scenario by looking at the outcome of the accuracy itself. So if you look at the overfit, sometimes it will be involved rigidity, means that it's too rigid, and it look at in two cases, yeah, very focused on certain cases, or what we call these cases will be reflect to the type of attributes, the value of the attributes. So that yields the results of overfit itself. Okay, and other than that, it will be underfit, which actually it cannot it learns something from the data set, but at the end the model cannot give really accurate results in terms of when we have a new data, when we have a new test data, it cannot give a high accurate prediction. So this is what we call as the not learned enough. Okay, definitely it will be depending on the data itself, or is depending on the algorithms that we are using, yeah. So ideal model will be, we are not going to say that underfit will be the good model, overfit will be not a good model. Okay, you could see like certain scenario when the analogy was like an athlete lah. Yeah, if you look at an athlete, there are certain people, certain athlete that will be very suitable in terms of doing some kind of short distance and also long distance. So short distance, uh, this athlete, for example, athlete A will be suitable for very fit for doing the short distance, but not necessary short distance will be athlete for short distance train for the short distance will be suitable for long distance athlete apa nama events. Yeah, so the training, it means that the training process will be very important. Okay, so if you look at this, yeah, this will be the ideal model, which when we look at, there is what we call apa nama where we can see there is a gap, yeah, there is a gap between training and testing. Okay, but it's not too small. When it's too small like this, it's actually, yeah, it shows some kind of underfit, yeah, underfit problem. I mean, the error of training is high, yeah, and then the error of test also high. So it is a model that is underfit, yeah. Both scenario for test and also for training produce a very high error rate, yeah. If you look at overfit, yeah, when overfit, yeah, the test will produce, yeah, the test will produce a high error rate, yeah. Meanwhile, for training, yeah, it will produce very low accurate, yeah. Sorry, error, yeah. So means that is highly accurate lah. Okay, so there is a big gap between training and testing. Okay, so it shows that the model is overfit. Yeah, and then this will be the, I mean, in the middle, at the middle of the apa nama, at the middle of these problems, you could see where we could have optimum, yeah, optimum, which it definitely will produce some kind of error to the apa nama, to the test set, yeah, and also training set. Means that it will complement, it will learn, yeah, it should learn from the training, and the apa nama, the new data set, yeah, the new data set given to this model will also give some kind of error. So this process not definitely it not been done by one iteration only. Okay, to look at this, yeah, to look at this, if you look at it will be done several iteration. As you look at this example is actually representing the MLP. Okay, if you look at number of nodes, yeah, number of nodes, number of nodes for the hidden layer will be different. Okay, same goes to the decision tree also, yeah. So the decision tree can be done iteratively by using different, for example, measures, yeah. As you, or what you have done before is about using the information gain. Okay, might later on you want to apply different measures for the training. So you could have this, yeah, this parameter will be represented by different measures. Okay, and you could see which of these, yeah, which of these will yield the high accuracy, yeah, for the apa nama, for the test training. Okay, and low accuracy, yeah, consider like low accuracy for the test, yeah. Alright. Sorry, not low accuracy, high accuracy. Kan saya pun dah confused. Okay, so high accuracy because this is the low error rate, yeah, error rate for the model. Okay, right. Okay, if you look at another view of the what we call graph, yeah. So as you see, this is underfit, which is very simple, very simple. It just presenting the separation line between two classes, by using linear regression, by using a straight line like this. Okay, if you look at, there are numbers of different different classes here. It be defined as another class label. Okay, so this will be producing the error here. Okay, meanwhile for here, if you look, if we use another some kind of representation, this could be what we call as the this is linear regression. This probably a log um, representation. So you could see here and here, okay, you could see it will reduce some kind of error because this is considered in the same class, but still there is error here. Okay, masih ada error lah di sini. But if you look at the overfitting here, it's very it's producing kind what we call curvy, curvy lines. So it would be detecting each of the object in the right class label. Okay, but what's the problem with overfit? Overfit because it will learn very much on the training, but when we give it another data set, it might have problem. So if you remember here, just now, so in the training, it produce very high accuracy, but in testing, it will produce a very low accuracy. Okay. So this will be the problem of the of the model. Okay. So later on, we are going to look at deal with the accuracy and also measures. The important part is that if we have a data set, okay, what will be the data types, and then what algorithms would be suitable for these data types, okay, and how we are going to determine the model that have been developed would be the best algorithms. It can be calculated based on the accuracy, and from that we can determine, whether this is a optimum or fit model, or whether it's underfit or overfit models. Okay, so far any questions? Ada soalan?
No.
No.
Okay. Alright, so I'm going to share another slide. Will be related to the related to the how you are going to calculate the accuracy itself. Actually, those accuracy has been a little bit discussed last time. Okay, hoping that you remember. Okay. Okay, so this will be the second part of the evaluation. We are going to look at measures that can be used to determine the model itself. Okay, so this, if you look at this table, we have accuracy and error rate. Actually, if you have the accuracy, do you think you're able to get the error rate?
Yes.
How? How? Normally accuracy is been calculated in the percentage, 100% kan, in the percentage. So how you get the error rate?
We get the values from the confusion matrix.
For example, you are given the accuracy of the model 70%. What is the error rate?
100 minus 70, then we get...
Right. Okay, so it's very direct lah. It's actually, and error rate can be also is being converted into float, which is 1. Yeah, 1 is in the range of 0 to 1. So let's say 100% is equal to 1. Yeah, so the error rate of the model, like what I mentioned just now, 70%. So if we convert to the float, 0.7. So the error rate will be 1 minus 0.7. You will get 0.3 error rate. Yeah. So it depends. It can be represented by the float or it can be represented by the percent. Yeah. And then other than that, we are going to look at the sensitivity, true, positive, yeah, and also recall. Okay, and then specificity and true negative rate. Okay, and this will be very these three lah. This measure will be needed. Yeah, you need to have the confusion matrix. Yeah, comparatively to the accuracy, you might not need to have to look at the confusion matrix. You just get it from the list of record that you have, and how many you can count it. Yeah, you can count it from the record itself. Okay, so firstly, let's have a look at the confusion matrix. So this will be once you run it in the weka. If you look at the weka, if you go to the classify, okay, and then if you go to the tree, choosing the tree, okay, and you will get the confusion matrix like what you see. Let me share screen for you. Okay. Okay, like you see here. Yeah, so this is the weka that once you have done it, yeah, you will get on here. This will be the accuracy, isn't it? So this is the accuracy. Actually, accuracy is calculated by correctly classify predicted versus the actual, and this will be the incorrectly classified, which is the error rate itself. Okay, and this will be the confusion matrix. Okay, right. Okay, wait. Mana saya punya ni? Okay. Right. So what is the confusion matrix? If you look at the confusion matrix, is actually this is presenting the column of actual. Yeah. So this is actual for class level 1 and then class level 2 or not C1. Yeah. And this is the predicted, means that the model predict the class, so whether it's predicted as class 1 or not class 1. Okay, if you look at this, true positive. Okay, I'm going to give you a very direct formula here. We have true positive and we have true negative. So what does it mean by true positive?
It was correctly classified.
So it is actual. The actual is class 1, okay, and is predicted as class 1. Atau macam Kamaru kata tadi, is correctly classified. And then what is true negative? Yeah, actual is not class 1 and the model predicted as not class 1. So this is true negatives. Okay, Meanwhile, when we look at this one, there is false positive FP and also there's false negative. So false positive means that is not predicted the right false means that is not predicted the right class label. Okay. So actual is class not class 1, okay, and is predicted as the class 1 ataupun as positive. Yeah, here meanwhile this one, okay, meanwhile this one, is actual is positive but is predicted as negative. Okay, so I'm mixing the term here so that you could capture it. Means that there is a lots of term can be ataupun a lots of it's lots of terms. Sometimes we call it class 1, class 2, not class 1, class 1 or not class 1, and then sometimes we call it positive and sometimes we call it as the negative. Instead, C1 here is actually positive, okay, and then this one, the other group ataupun the other class label will be called as the negative. Okay, boleh pick up? Is it okay?
So far, faham.
Alright. Okay, thank you. Okay, so for example here we have a problem. We have a data, given by all electronics, and then you want to know whether the customer would like to buy computer or not. Okay, so this will be the model that we imagine that we have run it in the model decision tree, and then this is what we get. Okay, so here, this is positive, this is negative, so from the confusion matrix, can you get what is the true positive? What is the value of true positive?
6954.
Okay, good, thank you. And then what do you get for the false positive?
2588.
To false positive. False positive di mana?
46.
Itu false negative.
For 1, 2.
Oh, 412.
Yeah,
Oh,
okay.
okay.
So, nampak sini adalah predicted as positive. Okay, predicted as positive. Tapi sini actualnya dia adalah negative. So, we call it, bila dia predicted selain daripada the right ataupun the actual class label, kita anggap dia sebagai false. Like what you are doing COVID-19 PCR is prone. I heard that is prone. I'm not sure lah. There is no statistics about the data, but I heard that PCR is actually prone to negative. Meanwhile, for the RTK, it will be prone to the positive. Means that not necessary if you have given a positive result of COVID-19, you need to redo another test on the PCR so that PCR can confirm that this is a positive or negative. Okay, so RTK could be actually the rapid test. So it consider if you have negative results, it will be safe, But if you have positive result, then you need to do another test to confirm about to confirm the existing of the virus. Okay. Sorry. Okay, back to here. This one. Okay. So again, so this one is true positive. Okay. So when it is predicted as positive but actual is negative, so we call as the false positive. Okay, and then the actual it is a positive but is predicted as negative, then we call it false negative. Actual it is a negative and is predicted as negative, so this is a true negative. Okay, boleh follow? Can you follow? Okay, so from this confusion matrix also, you would able to get the count, with what count? Okay, so here is the count of the actual positive, means that the count from true positive plus false negative. right? And this is the count of the negative, yeah, the class level negative. 4.12 plus 2588, you will get the 300. And this is predicted of positive, and this is the predicted of negative, and this is the total count. So it's like a ledger, maksudnya this one, yeah, total of 1,000, and this one total must be equal to 10,000. Okay, right. If you look at the class level of the, yeah, what is the accuracy of the class level each? Yeah, normally we will get the accuracy of each class level first. Means that how many accurately classify for class level positive, and then how many correctly classify for class level B, and then how do you get 954.42? Any idea?
Average.
And yeah, good, thank you. So this is the average of from this class level. Okay, so if you have more than 2 class level, yeah, it will be more complex. Yeah, I will share it later on. Okay, right. So like what I said, yeah, accuracy also can be calculated from the from the coefficient matrix, which is true positive and true negative divided by the total of each count. Yeah, and then when meanwhile, yeah, error rate will be can be represented in what we call apa nama, in the float here. Yeah, 1 minus the accuracy, or it can be counted from the false. Yeah, false. Okay, this is what we have discussed just now. Okay, so other than that, we could use okay, before we go to the sensitivity and specificity, so can you reflect to the what we have discussed on the just now on the overfit and also underfit and also optimum, yeah, boleh relate tak? Maksudnya now when we want to know whether the model is overfit or underfit, our concern will be looking at the accuracy. Okay, right? So imagine this is the accuracy of the testing. Okay, but to know the accuracy, to know whether this is a general fit or overfit and underfit, you need to have 2 set of accuracy measures. Means that the accuracy of the training and the accuracy of the testing. Probably this one, imagine I just make assumptions here. Imagine this is some kind that you get from the test. Okay, you need to look at the training recognition rates also. Okay, so normally for the training, your number of samples will be more from the test set. Okay. Okay. Continue with the sensitivity and specificity. So why we introduce sensitivity and specificity? Okay, this is actually very related to what we call having a class imbalance problem. Okay, have you heard about it? Pernah dengar tak? Ya, pernah dengar tak? Tak pernah. So if you look at the example here, one class may be rare, yeah, and then it could be a fraud detection data or medical data, like what you see nowadays. Yeah, if you look at samples of positive COVID-19, berapa ramai? Okay, compared to negative over the population of Malaysia. So we could see positive, yeah, will be the percent will be low ataupun masih ya lah, tapi saya tak ada nak kata, I don't defeat that the number is increasing, but I'm comparing to the numbers of population lah. Okay, so positive and compared to the negative will be high, yeah, positive will be low. Okay, same goes to the cancers lah. If you look at the cancers data, it could be related to the medical data. So the numbers will be low, positive will be high and negative will be quite low. Okay, like fraud detection. Have you gone through some of problem on the fraud data? Pernah dengar tak fraud data? Ataupun pernah I believe some of you have been called by the spam. Pernah dengar tak? Pernah dapat tak spam?
Pernah.
Kan. So berapa kali event berlakunya spam ni compared to the one that you know? Sedikit kan? Tak banyak lah tapi ada. Ya. But sedikit tu yang significant. I mean sedikit tu yang kita nak learn the patterns. Yeah, we need to learn the patterns. Okay, because of this scenario, yeah, we need to look at another matrix which is sensitivity and also specificity. When sensitivity will look at the true positive, yeah, whether the true positive will be high or or we are going to identify whether the true negative will be high. Okay, so boleh imagine tak? Can you imagine? Means that we have trained, we have gone through the process of testing, and then we want to know what will be the recognition rate will be higher, whether for the positive class or for the negative class. Okay, so it will conclude a lot. It will help us to conclude a lot. Based on the data set. Okay, other than that also we could have the precision. Okay, and precision will be based on the, just now we look at the what? Saya remind balik. Okay, sensitivity and true specificity will be looking at the row of the coefficient matrix. Means that true positive over the actual of positive. Boleh faham? Because we could have the actual of positive here and we could have actual of negative here. Okay. The next one is precision. Precise. How precise your model detect positive. Yeah. And then this will be look at the predicted. Yeah. So true positive. Yeah. Over the total of predicted. Okay. And then precision, and another one will be recall. Yeah. So recall will be looking at the completeness. Okay. Right. So precision will be go to the true positive itself, and then completeness will go to the how many positive labels as the positive. Okay, if you notice, recall equivalence to which formula?
Sensitivity.
Okay, good, thank you. So recall was similar to the sensitivity. Okay, specificity and precision will be different. Yeah. Okay, so what is the perfect score? Perfect score will be 1 lah. Okay, means that it can detect positive class level at high rate perfect score 1.0. Means that every tuples of positive is detected as positive. Every tuples of negative that is detected as negative. Meaning that the false negative and false positive equivalence to 0. Okay. So this will be the perfect score. Okay. Okay, let's have a look at example just now on the cancer. Yeah, if you look at the cancer data set, just now we look at the buying pattern. Okay, now we are looking at the cancer data set, which is more relevant to the imbalance data set. Okay, this one is true positive. Okay, and this one is true negative. And then if you look at false. Yeah, false negative is 210 and false positive is 140. Okay, so the total of tuples or total of records for positive, yeah, cancer equal to yes is 300. Meanwhile, cancer equal to no is 9700. So the total is 10,000. Okay, so firstly, you can get what we call sensitivity. Yeah. So sensitivity is from the TP, remember? TP minus the P. True positive divided by the total of positive. Then you get the 30%. Okay. And you look at the sensitivity. Yeah. Sensitivity reflect to the class level negative. Ataupun here, this is a no. Yeah. Cancer equal to no. So this is true negative divided by negative. The total of negative. Meanwhile, precision. Precision will be 2, 1, 2, 3, true positive divide by total of predicted as positive, precise. So 90 over 230. Okay. 90 over 230, you get 39.13. Okay. And yes, recall is equivalent to the sensitivity. Okay. So if you look at this one, this is 30%. And this one is 98%. Can you make a conclusion for this? Any conclusion? Yeah? Or you can conclude together with the accuracy given here. Anybody? Ada sesiapa boleh bacakan conclusion dia? Anybody?
So it means that the high accuracy must be above the 90%. So that ability to classify positive plus is low and ability to classify negative is high. So and the bottom one said that precision exactness equals to quality, recall completeness equals to quantity.
Alright, good. Thank you, Nazmi. Okay, if you look at the accuracy as a whole, it's quite good here, more than 90%. But if you look at the detail of the detection, it can detect negative class level better than class level A ataupun positive, isn't it? Betul tak? Betul tak? Okay. So this is only 30%, very low. Yeah, technically it's very low lah. Okay, we are expecting that it can achieve at least 80% lah kan. So we can confirm that this model have learned from the data ataupun have understand the pattern. Okay, but 30% is quite low. So how do you think this will be a good recognition rate for the cancer? There is, for example, the cases of that I said just now lah, RTK kan, betul tak? RTK. So kalau you gunakan RTK, you akan dapat result negatif. Maksudnya it can be confirmed that you memang tak ada virus tersebut, sebabnya based on the analisa here, it can detect negative much more better compared to the positive. But when you get positive, then you need to reconfirm with other process. Like in cancer also, there is certain process like being done. Firstly, it will take some kind of your cell to detect or whether it has abnormality or not. But before that, how they make the assumption that you need to be taken, the cell need to taken, it will be done through scanning. So the doctors might have done the what we call nama benda tu saya pun dah lupa, which is scanning. Scanning? Ultrasound. Ultrasound scanning, ataupun the doctors will ask for you to do some kind of CT scan or PET scan. Okay. Whether these images provide sufficient information or not, still not. So they have to go to the biopsy. So some samples will be taken from the body to know whether this is real, cancerous or non-cancerous. Sometimes it's only abnormality, means that there is no cancers on the cells, but it's only abnormality. Okay, so abnormality could not be dangerous. It could be stay in the body, without affecting, but if it be detected as cancerous, then it has tendency to spread to other cells and give some kind of jeopardizing the person. Okay, so these cells need to be, ataupun this certain part need to be removed from the body. Okay, boleh faham? Ataupun saya terlalu mengarut?
Madam, kalau dapat result macam ni, maksudnya dia bagus ke tak bagus?
Aha, what do you think? Kalau 30% rate, recognition rate.
Tak bagus kot?
Betul. That is the thing. That is need to be backup lah, macam tadi saya kata. There are certain test, bila kita dapat resultnya tidak mencukupi, then we have to look at another test. So 30% recognition rate consider very, very low. We expected to get this one at least 80%, right? So how you going to solve this problem? Okay, this will be something that would be a common problem in medical data set. So that's why what they have to do is that here, okay, 300 need to be top up. I mean the instances to be learned on the data set need to be gather more. Okay, whether you could have, you could not have, there's another issue lah. But enable in getting more, in getting more precise or more what we call accurate results for the modeling. So you might need to gather more data. Okay, so that will be one solution. Sometimes what they did would be instead of having 9,700, they could reduce it to the lower numbers so that the number of positive and negative could be almost the same. So this would be what we call resample, downsample the number of training data set. Okay, that will be another way of doing that. So that's why last in the in topic 3 you learn about sampling. Remember? Faham tak? Pernah ingat tak kita belajar sampling? Ingat kan? Yeah, sampling tu is very important because sampling will be needed here. Bila you nak buat, you want to gather the what we call accuracy and correctness and this incorrect classifier, you need to look at the samples too. Okay, taking much time in terms of describing this, because this will be very, very important in the machine learning, and you are going to carry this understanding throughout your studies. So apa-apa yang tak clear tolong tanya So ataupun kalau you ada benda-benda yang you boleh cerita balik, macam Hasif cakap balik tadi, Nazmi cakap balik, that help you to that
Madam lagi.
Hello, madam.
Madam. Tak dengar, madam.
Sekejap saya on balik.
Okay, dah.
Okay, alright.
Okay.
Okay.
Dia tak okay balik madam.
Okay, Assalamualaikum adik.
Waalaikumsalam.
Boleh dengar
Dengar madam.
Boleh, madam. Boleh, madam.
Right. Sorry rumah pun sampai 5-6 orang akses internet macam ni lah masalahnya. Okay. Right, apa yang saya share tadi? Saya tak dengar lagi suara perempuan. Azni ada? Azni? Senyap je. Yang perempuan.
Saya ada madam.
Siapa tu?
Ada, madam, ada.
Ada. Dayang ada? Ha? Jun Eka ada? Jun Eka? Ramai yang dah macam bertukar status je ni. Dah tak aktif.
Ada, madam.
Ada. Okay. Saya continue ya. Hopefully saya boleh speed up lah. So banyak lagi sebenarnya nak cover. Tapi saya speed up sikit ya. So ini adalah this one is actually somebody recording, isn't it? Huh? Okay. Okay, this part is actually looking at the multiple classes lah. This is a confusion metric. If you have more than 2 class level like what we have discussed before. So if we talk about multiple class level, it will be depending on the class level that we are looking at. Like we are studying about, for example, true positive for class level A. So what is the true negative? What is the true negative? So all of this becoming the true negative. Okay, right. In case you are studying about class level B, yeah, if you are studying about class level B, okay, if you are studying about class level B, so what is the true positive?
B.
Okay, good. How about the negative? How about the true negative?
Yang selain daripada B.
Okay, good. Yeah. So that will be the understand. You should understand. Yeah. So if you are considering the false positive will be. Kejap, saya tak boleh nak tukar pointer saya. Kejap. Okay. Yeah. If you are talking about the false positive, so these are all the false positive for class level B, and the rest becoming the false negative. Yeah, false negative. Okay, so this is how you look at the multiple class level. Please have a look at this. Yeah, later on. Okay, there will be another method. It could be used to determine. So it's using mean rather than using the count itself. Okay. Okay, and okay. So we have finished this part. Any questions? Any question about the confusion metric and so forth? Ada persoalan tak?
Ada.
Yang tadi tu kalau B dengan B baru true positif kan? Kalau yang B dengan C tu false negatif ke false positif?
Macam mana semula Ali? Macam mana?
Yang table tadi tu madam. Kalau B dengan B baru true positif kan? CP kan?
B dengan B adalah
true positif.
Maksud saya, kalau kita tengok kepada kelas level B, true positif adalah the detected, class actual adalah B dan predicted as B. Itu adalah true positive for kelas level B. Boleh faham ke Ali?
Itu faham madam. Kalau B dengan lain tu dia false kan?
Yes. Maksudnya kalau kita tengok pada kelas level B, ya, so itu adalah true positive. The rest maksudnya A, C, D dan E menjadi true negatif.
Maknanya kalau A dengan A pun true positif lah.
Kalau A sahaja, kalau kita tengok pada true positif, kalau kita tengok pada kelas level A, maksudnya A adalah positif, B, C, D, E adalah negatif.
Dia negatif je, dia tak ada tak ada false negatif macam tu kan?
Dia true positif dengan true negatif, and then ada false positif, false negatif tu adalah true. Okay, saya share balik di sini lah ya. Maksudnya okay, nampak yang ni kan? Let me share this one. Kan? So kita nampak di sini ini adalah untuk true positive. Okay. Oops. So ini adalah true positive kan? True positive of A. Kan? Yang ini akan jadi apa? Yang ini akan jadi
True negative.
false
False
positive.
Or false positive.
Kan? So false negative yang mana?
positive.
False positive yang mana? Yang inilah. Ni kan. Total, alamak saya punya kotak tak cantik. Okay, ni kotak dia. Boleh follow tak? Ini akan jadi Fn for A. Boleh?
Oh,
Corresponding row. Ya? Corresponding row. Exclude the TP. Okay? And then if I have another, we are looking at the B, kan? If we are looking at B, okay, so ini plus dan ini akan jadi false positive for B. Okay, and this one plus this one akan jadi apa? Akan jadi apa?
false negative.
Yes, betul. False negative for B. Boleh follow?
Okay, dah faham.
Alright.
Okay.
Okay. Okay. So boleh yang ini sangat penting lah sebabnya bila kita deal dengan multiple classes, you akan nampak dalam WECA. We will see in the WECA session later on. Okay. So let me share another slide. Yeah, satu lagi slide. I hope that I can finish it. Okay, so the next slide will be in terms of how we are going to increase the accuracy. Okay, so we already have done we already identify what's the problem of the modeling process. Okay, and then we know how to calculate. Yeah, we know how to calculate the measures. Yeah, related to the model performance. Yeah. And later on, next one, yeah, we have calculate the accuracy, yeah, and we say that how to improve the accuracy? Can we improve based on the same data set? Just now I also mentioned if you want to improve the accuracy, you can redo ataupun find or gather a new data set. Okay. Other than that, you can perform another methods of training and testing set. Training and testing process. Okay, so I'm going to show this one. Okay, it will be related to the what we call here. Firstly, is looking at the data itself. We can partition the data. Yeah, and this partition data will be two techniques. Yeah, you can have a look at hot dog method, or you can have a look at the cross validation. Okay, ini pun technical sikit lah ya. But the hold up method is very direct, means that you are dividing your testing and training based on certain portion of data. Like I mentioned, I already have introduced you a lot of example when the training must be containing more records. Okay, 2/3. Okay, meanwhile the test will be 1/3. Okay, but remember, when we do testing, the class label will be removed. Okay, and we measure the accuracy based on the test. Okay, based on the test. Okay, and when we applying hot dog methods or the split methods here, you would see that we can implement by using the random subsampling. Instead, we repeat certain times, yeah, depending on the how much time that we have to capture from the data. 1/3, like 1/3 from 100 could be only 10, yeah, 10 instances. So it should be repeated up to the 10 times. Okay. 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 So this is hot dog method sample. Sample example. Okay, it's applying the linear regression here, yeah, and then the blue one is presented as a training set. Okay, and then if you look at the red, this one red, 1, 1, 2, 3. Three data would be chosen as the test set. Okay, and linear regression, remember linear regression is for the prediction. Okay, so the predicted value will be in the numeric. So how to get or estimate the performance is by the distance of each of the predicted into the to the line, so it getting the mean of the line. So this is actually the gap between predicted and also this is the predicted, okay, this is the actual. Okay, so the gap will be showing the error of the what we call prediction. Okay, so Hodok method, but focus on the sampling. So Hodok methods must be training must be larger than the test set. So Hodok method is very simple implementation, but it needs large data set. Yeah, it needs large data set. Another example of ataupun the second technique is what we call as the cross validation. So what is cross validation? So cross validation is about dividing or partitioning, yeah, but it's the data will be partitioned into folds, yeah, several folds. Okay, so normally k equal to 10, yeah, k equal to 10 will be the most popular. If you look at WEKA, what we have done before, lots of by default, yeah, WEKA will choose k cross validation as a method of training and testing. Okay, what is folding? Yeah, what is k-fold? Yeah, this data will be mutually divided into subsets. Yeah, for example, you have 100 samples instances, so you divide into 10 folds. Yeah, for each fold will have 10 instances. We faham? Okay, for example, you have n equal to 100. Okay, and then you have k equal to 10. So for each fold means that k equal to 1. Okay, you have instance 1 until instance 10. Okay, k equal to 2, you will have instance 11 until instance berapa? 20. Okay, sehinggalah k equal to 10, which is this one is I berapa? I91 until I100. Boleh imagine? So this is the concept of cross validation. Okay, so let's have a look the process. Okay, leave one out. Yeah, let me show this one. Okay, leave one out means that for after we divide it into fold, yeah, after we divide into the fold, one fold becoming one fold will be like just now we have k equal to 10, yeah. Fold k equal to 1 will be the test. Okay, k equal to 2 until k equal to 10 will be the training. Okay, so this is for one iteration. Okay, saya patut kena buat dalam bentuk ni lah, sorry. I should put it in the white screen. Okay, so k equal to 10, I repeat, k equal to 10 means that we have k equal to 1. Yeah, so at this point, yeah, k equal to 1 is the testing set, and then k equal to 2 until k equal to 10 will be the
training set.
Okay, and then this is iteration 1 lah. Okay, and then iteration 2, what do you think? K equal to 2 become the test set, betul tak? Okay, and then K1, K3 until K10 becoming the training. Boleh faham? Okay, and it repeat until berapa tadi? 3 until I equal to Allah. Mana pula bilang saya? Mana tadi screen saya? Dah hilang. Okay, sorry. So it will be repeated until iteration 10, yeah, iteration time, where at iteration 10, full 10, yeah, k equal to 10 will be the test. Okay, the rest maksudnya 1 to 9 becoming the training set. Okay, so means that only one full will be the test. The rest becoming the training, and it will be repeat. So this is what we call as the cross validation. Kejap mana tadi? This is what we call as the cross validation. Okay, and the calculation of the accuracy will be based on the test, and it will getting the average by each of the full. Okay. There will be another methods under cross validation, which is what we call as the leave one out. Yeah. So each fold, for each fold means that we have 10 fold, is it tadi? Betul tak? We have 10 fold. Okay. So the test set will be extracted from each fold, and only one sample from each fold becoming the test set. Understand? Boleh faham tak? Can you understand?
Tak faham.
Tak faham. Okay, let me show you the diagram. Okay, right. So you have iteration 1, for example, yeah. So k equal to 10, 1 sampai k equal to 10 just now kan. So this is presenting the fold 1, fold 2, factory and fold 1. So instance 1, okay. And then dalam sini pun ada instance 1. So ini akan menjadi test. Okay. Instance 2 sampai 10. Okay. Instance 2 sampai 10 akan jadi training. Maksudnya each fold will contribute only one sample. Sebab dalam satu fold ada apa tadi? We have 100 samples. For each fold divide by 10 fold. For each fold will have 10 samples, 10 instances for in each fold. Okay, but we capture only one sample from each fold. Okay, so this is first iteration. Yeah, in total we will have 10 lah. Actually sebab kita capture 1. So in total we have 10 instances for the instances because we collect from the fold. Okay, iteration 2 macam mana? For each fold, the instance number 2 becoming the test, and same to the other fold. So instance number 2 becoming the test. Meanwhile, what is the test? What is the training? So the training will be I1 and then I3 until 10. Instance 3 until 10. Same to another fold. Boleh imagine? Can you imagine?
Boleh dah.
Ya? Yeah? Okay. Yang lain boleh tak? Naim?
Boleh.
Boleh nampak Yang lain okey? Yang perempuan? Syuhada?
Boleh.
Yang lain perempuan boleh? Gegel? Tim Gegel boleh faham? Okay.
Boleh.
Alright, so you faham maksudnya cross validation tadi we have just now, let's have a look at here, we have cross validation with k full, and then we have leave one out, leave on one out methods. Okay, boleh So this will be again, if I can conclude is that we have partitioning methods to do the pre-process, to do the training and testing process. One is using just now we have mentioned in terms of holdout methods. If you go through the buku lab pun kita dah mention pasal ni. And then another one is the cross validation. Okay, boleh Right, so yeah, this one I skip. Okay, please have a look at it. Okay, assemble methods, yeah. So assembles methods, yeah. So okay, just now hot dog method is suitable for large data set. How about the cross validation? How about cross validation? What do you think? Kalau hot dog method suitable for big data set, maksudnya you have thousands case, right? Thousands case. Cross validation show can you imagine is that in cross validation method is actually giving the opportunity of each samples in the data set becoming the test set. So this is a different cross validation and also hot dog methods. Hot dog you will directly split the training and testing, and then whatever instances becoming under the training will remain becomes the training set, yeah. Meanwhile, if you look at the cross validation, it gives opportunity to all instances become the test. Betul tak? Okay. So that's why hot dog method will be suitable for the large data set. Yeah. So we just divide it and then we run it through the classifier. But somehow you can repeat the what we call cross validation methods, yeah, several times to make even choices to the samples to be the to the testing. Just now we have mentioned about random sampling. Yeah, you can adjust so that somehow at certain iteration, yeah, different iteration of training and testing using the cross validation using the hot dog methods, different samples will be becoming the test. Okay. Meanwhile, for the cross validation, definitely you can see any instances, yeah, could be a test, yeah, because we will choose by sequence, yeah. For example, firstly we choose fold 1 become the test. Okay, next iteration fold 2 become the test. Next iteration fold 3 become the test. So each of the instance have the opportunity to be the test net, yeah. So and also it becoming the training set. So it's quite fair, yeah, fair to the these techniques, yeah. The model could learn better and make generalization much more better because it using all instances, yeah, using all instances. You could see the different later on, yeah, by using cross validation and also using hot dog method, which will produce better accuracy. Okay. Uh, and then, yeah, if we look at these methods, assemble methods, yeah. So assemble methods, they are combination, yeah. Assemble is actually combinations of models. Okay. So under assemble method, we have bagging and we have boosting. Okay, so what's the difference between bagging and boosting? So bagging is actually you have a collection of classifier. Okay, not necessary and a popular method is known as random forest lah. So you could have a different classifier if you look at this, huh? Yeah. So this as a classifier 1, classifier 2 and so forth. So we combine, yeah, we make a collective, yeah. This is what we call collective intelligence. We combine the decision of each instances from different classifier. For example, for instance 1, yeah, ataupun for record number 1, for record number 1, what is the decision of classifier 1? Adakah yes? What is the decision of classifier 2? Adakah yes? What is the decision of classifier 3? For example, no. So what would be the collective decision? Ataupun apa yang kita akan ambil di sini? What do you think?
Yes.
Yes.
Betul. So kita akan ambil yang yes lah. But if majority is predicting no, then the collective decision will be no. Okay, so this is what we see in the bagging methods. Okay, how about boosting? Okay, so boosting will be voting based on the votes of the samples pula, dia terbalik. So in this boosting, it will try to boost the using for example, it use different classifier, and then it will look at the samples of which sample will create error to the classifier. Okay, for example, you have I1, I2, okay, and IN. Okay, for example, I2, I2 give confusion, give confusion ataupun conflict for classifier 1 and classifier 2. So classifier 1 say yes, classifier 2 say say no. Okay, and then classifier 3 say yes. This is quite easy. Katakan kita ada lagi classifier 4. Classifier 4 says no. Okay, for instances. So these instances will be chosen later on as a training process. As a training process for the next iteration. For the next iteration. So the main point in the boosting is that it will choose the instance. Which instances can help the classifier to learn better. Okay, and it will focus on instances that produce the error, because it will look at the pattern of these instances. Okay, let me have a look at this. Okay, so this is a random forest. Okay, and then by averaging, and this will be looking at the looking at the classifier that need to be give some kind of weights, especially to the training tuples that will be misclassified. Okay, so at subsequence means after one iteration, another iteration, the classifier will inform to the next classifier. So please focus on this set of training, and then this training will be whether you could increase the weights of the for this training to be chosen as the training set, or not to be chosen as the training set. Okay, right. Okay, somehow there is a formula in boosting, is that when they identify this is problem, we have data that has problem always been misclassified by the data set, by the model, this data will be removed totally. So that is how they can keep on giving better results on that. So the data will be removed, and then they will be focused on certain data that can give much more better generalization pattern. Okay, right. And this part is on the WK evaluation that can be done in the WK lah. Later on we are going to discuss. Okay, so this is what we have. Classification of the how we can increase the accuracy of the classification through the training and testing process. Please have a look at ROC, and other methods that we are going to implement would be by using the assemble methods, and under assembles we can have bagging and also boosting methods. Okay, so we are expecting, yes, definitely when we have multiple classifier, it would be giving much more better results, yeah. And then it open to us to choose not only a single classifier. Okay, we could use many classifier, yeah, and definitely it help us to make decision lah, yeah. Okay, so what should I today what we have during the classification, yeah, and developing the model. Oh, ada satu lagi bahagian So I hope that you can go through later on. This will be the wrap up related to the wrap up, which is on the model selection, model selection. Please have a look in the future. Okay, so when you want to have a model, when you want to develop a model, we always have to depends on the accuracy rates. We always need on accuracy rate, and the accuracy rate will be determining whether this model is fit, whether the model is unfit, or model is overfit. Okay, we try to avoid overfit or also underfit. Underfit definitely dia sangat tak dia tak boleh nak, dengan training dia ada banyak error, dengan testing pun dia ada banyak, so there will be underfit. Okay, meanwhile for overfit, for overfit dia terlalu rigid pula, it's always depending on the training set. Using the training set, this data set they can detect correctly, but when you give a new data set for testing, it shows very low performance. Okay, that becomes problem on the ataupun this will be when you have more new data given to the models, is giving us inaccurate result. Okay, that will be for the overfit and underfit needs us to look at the data. We can gather more data, we can relook how you clean the data. Sometimes processing, the pre-processing task will influence, and you need to look back how you transform the data, look back how you disregard the data, or how to represent data. Okay, and then we use the confusion metric to look at the detail of how it detect the class level, each class level. So it's very important for us to look at not only overall accuracy but for each class level. Okay, and then when we already know, okay, the detection power of each, performance of each the model, we might want to, okay, how if I want to increase the accuracy? So we can look back at the methods of cross validation or methods of product method. Okay, or you can apply this the most recent one, which is on the assemble. So not necessarily depending on one classifier, you can use multiple classifier, or using the methods of boosting, instead identifying the right training set for boosting the classifier itself. Based on this, in conclusion, in selecting the model, not necessarily we look at the algorithms, but we have to look at the performance issue, and also time sometimes influence the selections. How times influence the selection is like how much time do you need to retrain, if you want to do cross validation, means that you have to wait until several iterations, several times, and be done. If you want to do just now hold up method, sometimes you could repeat, you want to repeat, but how many times? So that will be the model selection as well. Okay, right. So anything, I hope that I have shared you some of the phenomenon, at least a basic knowledge of the model evaluation. Anything you want to ask?
For now, no, madam.
Ada ya? Okay, kalau tak ada, we are going to discuss this model evaluation in lab session next week. So we focus on the to do some of the experiment to see the accuracy, the impact of the confusion matrix, ya. Dan juga next week saya akan juga project task.
Okay, madam.
Baik, madam.
Okay. Alright. So hopefully you boleh record you punya attendance, ya. Untuk group A petang sebab semalam saya tak buat record semalam, so minta tolong put your record, ya. So saya dah create satu slot untuk pagi ni untuk cover yang semalam.